Welcome to Tech Teach.
ALOHA protocol is basically divided into two different types. One is called pure ALOHA. Another one is called slotted ALOHA. So the first one we will be looking at, so that is the pure ALOHA network. So into the pure ALOHA network, so this is the structure given. So suppose there is station 1, station 2, station 3, station 4. Okay, so if this is the case and this is the time given, so this time is shared by everyone. That means it's like single station is a single suppose channel is there, and this channel is connected with 4 different stations, station 1, 2, 3, 4. Okay, so this is the channel. So at particular time, what is the packet position of each of the channels? So it is given here. So suppose at this time no channel has sent the data. At this time only station 1 has sent the data, that is having frame 1.1, means frame of station 1. This is first frame, it is there. Up to here also there is only one frame, so there is nothing to worry. Suppose at this point you can just see there is a frame only from station 3 and no other frames are there, so there is no worry. That means through this channel it can easily pass. But at this time there is a frame from 3, frame from 2 also, and that means at this point there is a collision taking place, because at this point through the same channel this one, both the station 2 as well as the station 3 both are transmitting, so there is a chance of there is a collision. And after some time, at this time the 3 channels are having this data on the same path or the same channel, so there is a collision. And after this time, this frame number 1.2, 2.1 and 4.1 are colliding. So this is the possible duration of collision in case of the pure ALOHA. Okay, and then further if we go, you can just see the time. So at this timeline, here the frame number 2.2 is there, and here the frame number 4.2 is there. So between here to here there is a collision duration. So that means first of all in pure ALOHA it is like anyone can send anytime, because only one channel is there that is shared between 4 devices. So anyone can send at any time, so there is a high chance of collision. So in case of ALOHA, basically there is a high chance of collision. Initially this random access or this ALOHA were designed for basically the wireless LAN networks, but nowadays same thing can be used for shared networks also. So when it is used for shared networks, so the pure ALOHA type, this is the structure of the pure ALOHA type, means anyone can send at any time, so there is high chance of collision. In pure ALOHA, this allows every stations to transmit whenever they have the data. Whenever they are having the frame, they will be able to transpose. A particular station is sending the data, it will be sending the data and then it will be waiting for an acknowledgement. So when there is acknowledgement that is not received in a particular allotted amount of time, there will be a timeout. Suppose it has sent the data. After sending the data, if acknowledgement is not received, it will wait for a random amount of time. So after sending, it will waiting for acknowledgement. This waiting will be till a specific random amount of time. So after sending the data one frame, it will be waiting for the acknowledgement, and this wait will be for random amount of time. So for random amount of time, it will be waiting. So whatever this random amount of time it will be waiting, that is basically called the back of time. So this back of time is called TB. Okay, that means after sending a packet, it will be waiting for back of time. So till back of time, if the acknowledgement is received or not, otherwise it will be sending the packet again. So that means TB is the random amount of time. So if suppose frame 1.1 is sent, then after sending this, other stations will be waiting for TB amount of time. So after TB amount of time, they will be sending the return. So these different stations will be waiting for different amount of time. So because each is having a random time, so each station will be having a random amount of time. Anyone will be sending the data with a random amount of waiting period. So once the data is sent, it will be waiting for a random amount of time. So that random amount of time, suppose TB1 is there, then this will be waiting for random amount of time, that is TB2. This will be waiting for a random amount of time that will be different from any other. Okay, so that is the random amount of time waiting period by sending a packet. Okay, so if each one is waiting for some amount of time, there is a chance like they can reduce the collision. Okay, so in this case, it is basically considered like, we can just proceed to the next. So this is the procedure for a pure Aloha. Here it will be, station has a frame, suppose it has received a frame from the upper layer, then it will be starting this k is equals to 0. So this k is number of attempts. So suppose this is 0th attempt, then it will be sending the frame. After sending the frame, it will be waiting, wait timeout time. So timeout time is 2 times the TP. So what is the TP basically? TP is basically the maximum propagation time. Means after sending, whatever the maximum propagation time is suppose TP is the time till that the data should have reached to the receiver. So it will be waiting till 2 into TP time. If till then acknowledgement is received or not, if it is received, that is success. If not received, then it will be attempting to resend the data. So k plus 1 times. So this is the what number of attempts it is there. And then it will be checking the attempt, number of attempts. So number of attempts is maximum k, maximum is generally considered to be 15. It will be sending a same frame 15 times. So if 15 is met, then it will be aborting the send. Otherwise, if 15 is not met, then it will be randomly selecting a number. Then the waiting time, TB time, that is the backup time will be here. TB is R into TP, that whatever the propagation time or propagation maximum propagation time is there, into that R times R will be randomly, because randomly it will be waiting for backup time. So this is the random backup time. After random backup time, it will be sending again the same packet. So either it will be like the propagation random time multiplied by propagation time, or R into TFR. So here FR is average transmission time for a frame. So either propagation time or transmission time for a frame, that is we can consider both are similar thing. So this is how the procedure is followed for pure Aloha case. Here an example is given. So it is basically saying like, if a station on a wireless Aloha network are a maximum 600 kilometer apart, and if we assume that the signal propagates at this speed, then we find like TP, what is the propagation time. So this is the distance and this is the speed. Then time will be distance divided by velocity, that will be given by 2 milliseconds. 2 milliseconds is the propagation time of the data. So now we can find the value of TB for different values of K. So if we are changing the K, then what will be the value of TB, that is the backup time that is given. So here K is 1. So K is 1 in the sense that this is the first time. So in this first time, the range will be, the maximum range will be like, because here random range is going to give like, random range is between 0 to the power K minus 1. Okay. So if this is first attempt, so to the power, the range will be like between 0 to 1. So if range is 0 to 1, then the maximum TB that can be there like 0 multiplied by 2 or 2 multiplied by 1. So this will be the maximum one will be 2 milliseconds. That will be the TB. So next is the case like if K is equals to 2, in that case the range will be like 2 to the power 0 to 2 to the power K minus 1. So this is between 0, 1, 3. If this is the case, then TB times. So TB times will be randomly taking R multiplied by T propagation. So 0 multiplied by 2, 1 multiplied by 2, 2 multiplied by 2, 3 multiplied by 2. So this is the time, the different backup times based on the outcomes of the random variable. Similarly, if K is equals to 3, then the range will be this. If range is then this, then the backup times will be like 0 to 4, like 14 milliseconds likewise, based on the outcome. Similarly, if this is the case, but here it is saying like if we need to mention that if k is greater than 10, it is normally set to 10. That means when the k is coming out to be 10, more than 10, at that time, generally here the maximum value of k is given like 15 can be there, but generally for analysis purpose, if the k is greater than 10, then generally we will be stopping at 10, k is equals to 10. So up to k is equals to 10, the analysis will be done. Otherwise, that process of sending that frame will be aborted. So here the vulnerabilities are given. Vulnerabilities in the sense, what is the problem into the pure Aloha is like, suppose one frame is sent, and here the beginning of one frame and the end of another frame is colliding. So A is end and C is beginning. Here B is end and A is beginning are colliding. So then what is the vulnerable time? So vulnerable time is considered to be like, so this is this one time considered like, this is the TFR. So TFR is the frame transmission time. So what is the frame? Like if B frame is there, so for transmitting frame number B, FR time, TFR time is required. Then whatever the FR time is there, multiplied by 2, this will be considered as the vulnerable time. So that means up to this amount of time, there is a possibility of error, or there is a possibility of collision basically. So that's why it is called like T vulnerable time basically. So here a question is given. You can just see that question. What is the question is? So in case of pure Aloha, the throughput is given by like S is equals to G into e to the power minus 2G. And the maximum throughput, that is S maximum, is equals to 0.184 when G is equals to half. So what is here G is basically, so this G is considered as the number of stations wish to transmit in the same time. If suppose what G amount of stations are going to want to send the data at the same time, then the throughput is given by S equals to G into e to the power minus 2G. That is in case of pure Aloha, and maximum throughput that is possible is 0.184 or 18.4% basically. So that is when G is equals to half. This is the analysis that is there for pure Aloha. You can just go through this question. It is basically to find out like how we can find out the throughput. Throughput when we are sending 1000 frames per second or 500 or 200 frames per second, then what will be the throughput? So here frames that are frame size is given and the channel size is given. So if frame size is given, channel size is given, the frame transmission time will be given by like 200 divided by 2000 kbps. So it is similar to 1 millisecond. So 1 millisecond is for like sending one frame. But here it is saying like 1000 frames per second. If 1000 frames per second, that means 1000 frames per second means here the load is 1. Load in the sense G is equals to 1. If G is equals to 1, in that case, what will be the value of throughput? In one case, one, if load is 1, then this will be the throughput, or this is the percentage of the success or efficiency basically. Similarly, if the load is 1000 frames, so load in the sense number of frames is 1. That means suppose load is 1. Load is 1 means only one is the sender. If only one is sender means one frame is sent. In that case, this is the efficiency. Then if 1000 frames are being sent, then this will be the efficiency. Okay, that means out of 1000 frames that is sent, only 135 frames will be reaching efficiently. Similarly, we need to find out for 500 frames per second and 250 frames per second. So for all the cases, the load will be changing. Okay, so if the load is changing, then what will be the value of the throughput? You need to find out. The second type is slotted Aloha. So one of the disadvantages of the pure Aloha is anyone is able to send the data whenever it is having the data. They are going to send by just and after sending, they are waiting for a random amount of time. But in the case of slotted Aloha, what is there is this complete channel is allotted into a different slot. Slot 1, slot 2, slot 3. This is given. So different slots are given into the slotted Aloha. So here, this is basically developed to increase the efficiency of the pure ALOHA. So here shared channels are divided into different discrete time slots. So in that fixed time slots, only the frames will be sent by each station. Sending of the data is allowed only at the beginning of slot. So at the beginning of the slot only the data can be sent. In that case, the vulnerable time is only transmission time of the frame, not like 2 times transmission time, it is the transmission time. So it is basically going to reduce the waiting time, and also it is going to reduce the delay, and it is going to increase the performance. Okay, so this is basic idea about the slotted ALOHA. So slots will be there. In that slot beginning only the data can be sent by each of the station. So if station suppose missed this slot, it could not send it in that at the beginning of the slot, then it has to wait till the next slot is coming, then the data can be sent. So this basically reduces the probability of error. Slotted ALOHA, the throughput is given by like G into e to the power minus G, and the maximum throughput is governed by the value like it is 0.368 when G is equals to 1. When G is equals to 1, the maximum efficiency is like 36.8%.